Okay, so now let's put that onto the model that we're going to look at. Again, that was a lot of math and just kind of setting up. Now let's actually draw it up. So what we're looking at with the production possibilities curve is what is the opportunity cost of making a gun. We need to start over here, and we call a setup like this a table, but in economics we call it a schedule. So what we're going to start with is, okay, well, we remembered that if we take all of our factors of production and make only guns, well, I can make 5 guns. But if that's true, how many butter am I making? Well, I guess I'm making 0. Okay? So now, if I choose to make, I'm like, okay, well, I don't just need guns, I need some butter as well. Now we need to figure out, okay, well what's going to happen? So, if I choose to make some butter, if I'm going to make 4 butter, what that means is now, because I took some of these factors of production, and instead of making guns with them, I made butter, well, that means I can make less guns. Okay? So now this is going to be 4. Okay? As this continues to go down, as we continue to make 1 less gun, this is going to go up. So now I could make 8 and 12 and 16 butters. And if I wanted to make only butter, if I were going to take all of my factors of production and devote them to making butter, that would be 20. But then I would be making 0 guns. By the way, guns and butter is just a classic economic, if you look in most textbooks, that's what they're going to use. I don't know why, but it's what we use, and I guess it's kind of funny. Anyway, the production possibilities curve is this graph right here. It's not done yet. We're going to make it together. So let's look at how it's set up first of all. So you know, we do use just your standard mathematical grid here. So this is your y-axis and your x-axis. We don't show the other quadrants because in economics we only really deal with positives. You can't really have negative guns or negative butter. You can only have positive guns and butter. Therefore, we only deal with the positive quadrant up here, so that's all we ever draw. But it is actually the exact same thing as you would be seeing in math. We don't always have to scale these the same, so you notice it's roughly the same distance, and this goes 1 to 5, and that goes, 0 to 5, and that goes 0 to 20. And that's okay. We don't need to do that in economics either. Okay, so what we're going to look at is we're just going to graph these points in. Really, really easy. So if I make 5 guns, right, then I have 0 butter. So there's that. If I make 1 less gun, 4, then I can have 4 butter. And this should just go all the way down to here. 8 and 3 should be about there. 12 and 2 should be about there. 16 and 1 should be there. And we get this nice little straight line there. Now a couple things. First of all, you can see that's maybe not the straightest line you ever saw. For the most part in economics, and I'm just talking, you know, for your future life in this class, for the most part, sketching is fine. You don't have to be super exact. For paper 3, we'll talk about paper 3 later. If you're HL, if you're SL, you can tune out for a few seconds. For paper 3, you do need to be exact. You need to use a ruler and really measure things out and make them perfect. But for most parts, it's fine to do it just this way. Okay, so what we're showing here is this line is the production possibilities curve. Sometimes, again, other people call it the production possibilities frontier. And what this represents is 100% of factors of production are being used if we're producing on that line. Okay? Now again, do we have the possibility of producing there? Can we make 5 guns and 4 butter? Well, according to this, we can't. Right? This says that if I'm going to make 4 butter, I give up the ability to make 1 gun, so that isn't possible. That's beyond our frontier. It's beyond our production possibilities curve. Okay, that's good enough for now for this. So let's move on. Let's see how we can be a little bit more efficient. The example I just gave you, where you're only looking at guns and butter, you're only looking at the two products, is very simple. It's very introductory. So let's look at something a little bit more complex. We're still going to look at two products. We can paint houses or we can dig ditches. But now we're going to look at, instead of all the factors of production just grouped together, we're going to break them into three parts. So here, our factors of production, well, we've got Bill, Joe, and Chris. And let's look at what they can do as individuals first of all. Look at these numbers and, take a second and just allow yourself to make a couple of conclusions. Okay, we can see pretty easily that Bill is the best at painting, right? But at the same time, he's the worst at digging. Who knows why, it doesn't matter, but Chris, he's the worst at painting and is the best at digging. He can dig 50 meters of ditch an hour, where the other two can only dig 20 or 10. So, we could look at it as totals, and if you looked at this down here, it would be very similar to what we just looked at. You can make you can paint 800 square meters of house an hour, or you can dig 80 meters of ditch an hour. You can look at it that way, but let's try to be a little bit more efficient. So, when we look at efficiency, remember this problem of scarcity that I talked about, or that we've looked at already. Because scarcity is a problem, we want to reduce it. And really the study of economics is about reducing the effects of scarcity, making scarcity less severe. So, if this is true, well, the opposite of scarcity, or the way that we reduce scarcity, is by being more efficient. This means basically using my resources in a smarter way. So, let's graph this out real quickly. Let's do the math with the totals. Okay, so we're going to say, all right, well, we can the maximum amount we can dig is 80 meters per hour, and the maximum amount we can paint is 800 square meters per hour. That would reduce then, for every meter of ditch we dig, we give up the ability to paint 10 square meters. So, let's take that over here, and I didn't color it in real well because I'm going to get past it in a second, but these dots here, here, and here, as well as the origins, those would represent the exact same thing we saw on the other diagram. So this straight line here, that would be our production possibilities frontier, which in theory you can't go beyond. You can't make more than something on that line. But we're going to see quickly here, by being a bit more efficient, it's actually really easy to make more than that. Look back at these numbers, and let's focus right here. This is 440. So this dot right here, we can call it A, point A, is saying that if you're going to dig 40 meters of ditch, then you can only paint 400 square meters of house. Let's look back at the numbers and see if we can't do better than that. Well, that 400 number should jump out at you really quickly, because we actually see Bill, he can do that on his own. So if Bill were to do all the painting and leave the other two guys to digging ditches, well, we could actually figure out a way where now we're doing 400 here, and we're able to dig not 40, but 70 meters. So that would be 400, and now 70 out here. So this point wasn't as good as that point. So this is true in lots of cases. We could, we could have only Chris dig ditches, and then Bill and Joe, they could both paint. So now we could be at 50, which is here, and 650, which is way up here. So instead of this line that we would have had, again, that would have been where everybody was just working at the same time, and we do half of our day painting and half of our day ditch digging, or 2 hours digging ditches and then the rest of the day painting. Well, we can see by breaking up the tasks and allowing people to do what they're better at. Bill is better at painting. We should let him paint. Chris is better at digging. We should let him dig. Joe's kind of a jack of both trades. We can see he's maybe a little bit better at painting than digging, so maybe he could split his time. So this line, which again in theory was 100% production, we can see that we can actually do better than that. And that would be this convex curve here. So by specializing, we made ourselves more efficient. Notice we still can't do better than 800 or 80. That was our maximum. But we can do better than the trade-off that we saw in here. Okay, to wrap up just a few things. When we look at the production possibilities curve and we see it with a straight line, we're not thinking about specializing our resources. And again, we can think about our resources. Is some land better used for one thing than another thing? Well, sure it is. If you have a big flat piece of land, that's really good for farming or putting a factory on. Well, if you have a very heavily wooded piece of land, maybe that's not the best place to start a farm. So we can think about here, this is showing, okay, well there's a trade-off. I can't produce all the guns I want and all the butter I want. I have to trade off one for the other. But by being a little bit smarter with our resources, well, we can push this out and we can do a little bit better in between. Okay? So this is kind of efficiency. Again, it's a big goal of economics. It's something that we'll look for a lot. And it's essentially this idea of working smarter and not working harder.